Welcome back to other exercise. We'll exercising on branching. Okay, so we have a problem named outfit of the day. Chelsea Slan wants to go on that with a man whose initial is V, and she's confused about choosing the right outfit. When she opens her wardrobe, she has this. See, if you read the question, you didn't get the idea what the question actually wants to do. If you want to focus on input, output, and explanation first, you understand everything, okay? Not everything, but the concept of the question, you understand it. Input, output, explanation. So from here, we see two kinds of output, match or not match. Simple like that. And for the input, it's always three inputs. Okay, so for the identification only, we can know the concept. So from there, we go back to the question, what it wants to do. Chelsea wants to go date with a man, blah, blah, and she is confused about choosing the right outfit. When she opens her wardrobe, she has these three variables. So we already know from this question that it has three variables you want to input. It's the shirt colors, pants color, and shoes colors, right? Help Chelsea choose a combination of her outfit of the day following these rules. This question is so kind for you guys. It makes you the diagram. You can use it. It's a tree diagram that you can use branching things because when you visualize branching, it's like this. Okay, this is the visualization of branching. Okay, so if just read it like that. We do English and we translate it to code because code is so close to your English pronunciation actually. So if the shirt is pink, trousers is white, the shoes is white or black, it doesn't matter. It will output match, right? But if that combination outside that combination it will not match, right? That okay, and you can read it the white, the beige. Okay, so like before, when you write an algorithm, you always do things like this. Okay, this is the template that you will always do. As I say before, no need to rushing into dictionary, working top to bottom. We can go from algorithm first. So what we know from our identification of question that we have inputs, right? First we have input. Oh, actually, I write the dictionary. Why do I do that? Because we already know that there is a three variables, shirt, pants, and shoes. But don't do that, okay? Do algorithm first. We have input, shirt, pants, and shoes. What we do, if we look to the how I do split screens, how I do this split screen. Okay, so so. Okay, this is how you do it. This is the diagrams, right? So I'm gonna just copy that and give it to the. If you guys see this, it's okay. It doesn't matter. And you will guys see it down here. Okay. Back to the question. To make it simpler, we have this, okay? We have input 3. So if the search ping always working on a smallest problem, do ping, after that white, after that beige, and this is what you do. If the search ping, then the branching will go checking the trousers, the pants, right? If the search ping, you need to check the pants. If the pants is white, do we need to checking the shoes here? I think not, because we only have two shoes. Chelsea only has two shoes, right? It's white or black. It doesn't matter, so we didn't need to check the shoes, right? If the pants is white, the shirt is pink, the shirt pink, and the pant is white, it will instantly output match, right? If it not do that, the pants colors is not white, then it will output not match. We didn't need to check the shoes. So from this concept, you already think that if is a expensive operation, okay? If it's an expensive operation. So try to keep it simple and readable, okay? So for the next one, what we need to do is checking the search if it's white, right? If it's white, then don't forget about the end if. Every if always end on end if, right? So else if search is white, then we have four to choose from trousers, okay? If you guys see on here, it has this. So there is three there is three colors of trousers that match with white shoes. Okay. So if the color of the pants is gray or brown or white, we will check it as one time checking, right? So if you listen to my pronunciation before that I say it gray or brown or white, just write it on the code, right? It will be like this. If pants gray or pants brown or pants is white, oh, sorry, there's maybe a typo on this. It needs to be gray with A or E. It doesn't matter. It's only the different on American and British language, but stick to the algorithm. If it's or, it's using or. So we checking three as a one condition, right? Then, do we need to check the shoes on the before the algorithm before? We didn't need to check the shoes, okay? Because white or black, it doesn't matter. It's a match, right? But in her condition, we only need to it only good with white shoes. So we need to check the white shoes. If shoes is white, then the output will be matched. Outside that, the output will be not matched. Did the algorithm stop here? No, we need to check the black, right? The second one. Do we need to use or and? No, we didn't need to use because it's only one variables, right? So one values. Sorry. Else if the pants is black, it only good with black, right? So if shoes is black, then you output match. Outside that, output not match. Like that. And for the last one, for beige, okay, we need to check two branching. We need to check brown. We need to check white, okay? If we look at this, look at here, brown is good with black and white. Same like the first problem. So we didn't need to think about the shoes, right? Checking brown, it will be if the shirts beige and trousers is brown. After that, we didn't need to check the shoes. We just output match, right? And that's what the algorithm says. Okay. Why I use else here? Okay. For this, the correct thing is to do else if, right? Using else here will be some kind of non-logical algorithm, right? So if I just write random strings, maybe I don't Chelsea didn't have green search, but I write it green, it will go to this because it's else. Anything else beside pink, white, and beige, right? So the good algorithm here is else if, not else. But why do I write else here? To make you guys see three views of if. Here is if, else if, and else, right? Okay, so writing this, you can be right, but I advise you to write this as an else if search page, okay? But I use else here, okay? Nothing's wrong, okay? Nothing wrong. But one is better. If pants were brown, then output match. Outside that, output, do we need to output it? No, of course. We use else if pants white. We need to check these shoes because it only match with white, right? So if it white, it match. It, not that it's not match. Never forget this. And if, right? Never forget about that. Okay, so that's for our second exercise. This is